This video will look at dominance matrices. Dominance matrices are used to rank objects in a network. They are most useful and could be useful when ranking players in a round-robin tournament. But they can be used for any sort of ranking system where there is a connection between the points of interest. So suppose we have 4 players competing in a round-robin tournament. During the tournament, we know that A has defeated D, C has defeated A and D, and B has defeated A, C, and D. What we want to do is just draw a directed graph to show that information. So if we draw the directed graph to show that information, we have our links A, B, C, and D. So we know A defeated D, so we're going to draw a straight line and put an arrow on that line to show that. Arrow's a bit. We then know that B defeated A, C, and D. And we know that C defeated A and D. Alright, so our directed graph should look something like this. From here, what we can do is then draw a dominance matrix to show that information. So before we're doing a connectivity matrix and we're labeling them with C, your dominance matrix is going to be a D. So we're looking from, obviously our diagonal we know will be zeros because they can't play against each other. Okay, so that we know that A lost to B, so that we write that in with the 0. A lost to C, which is a 0, but actually defeated D, so that becomes a 1. If we look at B, B defeated A, defeated C, and defeated D, so they won that, so therefore they get a 1. C defeated A, so that will be 1, 0, 1. And then D was defeated throughout the tournament, so it would come up with a 0. So we have this information, our dominance matrix here. What we can now do is actually rank based on that information. So when we rank them, what we're doing is we're adding up each row. So if I add up the rows for the values of the row in the first one, I get 1, then I get 3, 2, and 0. So that implies that if we were to rank them, B would be number 1, C would be number 2, A would be a ranking of 3, and D would be the ranking of 4. If we now jump to the next slide, sometimes we might have more players, and at the end of calculating, we have a dominance matrix where the row sum has the same values. Alright, so after completing a round robin tournament of 5 players, we can see that C is finished on top, A, D, and E are sitting second, and B is sitting third. What we don't like is the fact that A, D, and E are all equally ranked. So what we might do is consider the second order influence. So the second order influence, to calculate that, we calculate D squared. So what we can see is E has beaten B, and E has beaten C. C has beaten A, and B has beaten A. Alright, in our columns here. When we look at the 2 in our last comment shaded section here in the D squared value, we get that because E's beaten B and B is beaten A. So the likelihood of E beating A is higher and increases the influence. When we start looking a bit further, we don't like to rely on the D squared value very much. So quite often we will calculate a supremacy matrix, and that supremacy matrix can be calculated by D plus half D squared. We just try to use the half to reduce the second order influence when added to the first. So if we use the supremacy matrix result, what we can see is now we can get a bit better ranking. So A and E are still equal, but now we can see that D has been pushed down in the rankings. So sometimes we might even consider to go further and have a look at the third order influences, or even go further again and look at higher order influences. Generally we'll stop at 3 though. We will also, if we calculate a supremacy matrix of the third order, we reduce that. So if we're looking at the third order supremacy matrix, we actually use D plus half D squared plus a quarter D cubed, just to reduce the reliance on the third order. If we have a look though, just in this example, when we get to D cubed, you'll notice that in this example, the leading diagonal has no 0 elements. And we know that A cannot play themselves, but this is happening because of the cycle appearance. So A is beating E is beating A, and therefore B is beating A. So we shouldn't place too much importance on these higher order questions, influences, which is why we would add a quarter to it. What I want you to do is have a go at the dominance matrix chapter. So exercise 9C, starting on page 260 are the questions. And see how you go with them. Some of the supremacy matrices you'll be completing there have slightly different rankings, so please take that into consideration when doing the questions, and it's really important just to analyse your results at the end.